Right, question 4 was a trig question. Generally, this was pretty well done, although some of you made it a bit more complicated than you needed to. The thing to do was to find this identity or use this identity. I think I said this when we went through it in class. The best thing to do with these types of questions, and I've actually done it right here. So start with this thing that we know. Okay, you can all remember this, I'm sure, that sine squared theta plus cos squared theta is equal to 1. Right, and in our question we've got cot squared thetas and cosec squared thetas. Okay, so let's think, what have we got to divide everything by that we're going to get an expression involving cot squared thetas and cosec squared thetas? In this case, we're dividing everything, so divide both sides by sine squared theta, so all the terms on both sides. Divide by sine squared theta. Sine squared theta over sine squared theta is 1. Cos squared theta over sine squared theta is the same as 1 over tan squared theta, so that's cot squared theta, and 1 over sine squared theta is cosec squared theta. You can then do a little bit of rejigging and get cot squared theta is equal to cosec squared theta minus 1. Okay, once we've identified this, we can plug that in. So we sub this into our original equation in place of cot squared 3 theta. Okay, having the 3 theta doesn't make any difference. So we've got 2 lots of that is equal to 7 cosec 3 theta minus 5. Rearrange all of that and you get to a point where you've got something like 2 cosec squared 3 theta minus 7 cosec 3 theta plus 3 equals 0. Okay, so to get to that point, you get 2 marks if you get to that point. Then treat it like a quadratic. Splitting the middle term, we get 2 brackets which look like this. So 2x minus 1 and x minus 3. Okay, what that equates to when we put our cosec 3 thetas back in is that, so cosec 3 theta is equal to a half, or cosec 3 theta is equal to 3. Now let's plug back in that cosec 3 theta is equal to 1 over sine 3 theta. Okay, so we've got 1 over sine 3 theta is equal to a half, or 1 over sine 3 theta is equal to 3. Okay, rearrange both those and you get sine 3 theta is equal to 2. Right, there are no solutions to that because the maximum value that sine of anything can have is 1. Okay, sine of x is always between 1 and minus 1. So then we've got sine 3 theta is equal to a third if we rearrange this thing highlighted in that red box there. If you rearrange that, you get sine theta is equal to 1/3. Now we're going to have to solve this. So we've got sine 3 theta is a third. What we need to do is solve it for 3 theta. Okay, and then we can divide that by 3 to work out what theta is. So we're considering theta between 0 and 180, which means we're interested overall in a sine function between 0 and 540, okay, because we're going to divide our final answers by 3. So I've just said, let's look at sine alpha as a third. Let's look at sine alpha as a third and consider alpha between 0 and 540. Okay, you might not need to do that step if you don't want to, that's fine. So then we look at our solutions. So first of all, we do inverse sine of a third, and we get 19.47, which is this solution here. Then we've also got 180 minus that same value. We've got 360 plus that value, and we've got 540 minus that value. I'd always recommend drawing the sine curve. It makes it a lot easier to solve it. So we've got our 4 values for alpha, and we've said that alpha is equal to 3 theta. So let's divide alpha by 3 to get what each of our theta values are. It tells us to round them to one decimal place, so those are your 4 answers.